All right, well, thank you very much for joining us in this session here. The point of this RobotX Forum is to get everyone together and to, as Daryl and Kelly said this morning, discuss things, share ideas in a lower stress environment than the competition itself. I think that's a big part of it. Is when you're actually at the competition, you guys who've competed know nothing's quite working right. You're not getting any sleep. The teams are really great about talking to each other, even under those circumstances. But it's not the ideal kind of environment to just shoot the breeze and kick around future ideas and things like that. So that's what really this is all about. And one amazing advantage that we have here at this forum is that we have a wealth of experience in organizing maritime robotics competitions here. And so rather than go to all the separate competitions and try to find some time to talk to the technical directors, this was just a golden opportunity for us to get some of the TDs of these competitions, one of which has been going for 20 years now, RoboSub, and sort of pick their brains a little bit, get them up here on the stage, get them to talk about their design philosophy for the competition and how they, what they hope to accomplish with their particular competitions and how they implement that. I think this is a really great opportunity to sort of get inside their heads a little bit in this setting. And with that in mind, we really want to hear from you guys in the audience when we get to the discussion phase. So this is your opportunity to have these organizers on the spot, to ask them questions about why they do things the way they do them, give them suggestions, all that kind of stuff. So please don't be shy to give your input when we get to the discussion phase. But the four competition organizers that we have here, we have Aamir Qaiyumi, of course, the RobotX technical director, Dave Novick from RoboSub, Fausto Ferreira from the European competition Source E and what was Eurathlon and is now ERL, and Hayato Kondo from Robocon in Japan. So I'm not going to waste a lot of time doing more introductions of everyone than that. I'm going to call them up one by one to give a little introduction and presentation on their competitions and their design philosophy, and from there we'll launch into our discussion segment after that. So first up, because this is the RobotX Forum, will be Aamir, and I'll let him take it away.
Thank you again. This is the RobotX Forum, and I'm going to give a little bit of talk about. We've only had 2 RobotX events so far, so 2014 and 2016. Unlike a lot of the other competitions, we're biennial events, so we're slowly building a little momentum as we go. And so what I'm going to talk about first is kind of the design philosophy, the approach we took at the 2 events, and how it evolved. And later today, I'll be talking a little bit more about 2018 and about the long-term evolution of RobotX, where we think we want to go with it. So with that, I'll go ahead and start with the 2014 challenge. So we had 5 major tasks that we were given for the students to do. The first one is one that's a classic one that we've done consistently. It's a navigation and control challenge. Prove that you can control the vessel autonomously, that the system can drive the vehicle in a controlled fashion. That one is one that's been consistent throughout pretty much all the competitions from RoboSub on. If you can't control it, you can't really do anything else. So that's a big step. And then we had an underwater challenge. It was a surface challenge with an underwater acoustic beacon. And that was used to test, as most of us know in the maritime environment, acoustics is one of the big ways we operate. Just to be able to home on an acoustic beacon. It's very similar to what's been done in RoboSub for years and also RoboBoat. A lot of our challenges for the first year were actually in alignment with what had been done in RoboBoat as a way to kind of bridge the gap from the smaller competition to the larger vessels as well. We had a color perception challenge where they had a light buoy that had colored jumbotron material on it, that would flash different colors in red, green, and blue. And for that, they would have to identify the color pattern in which it flashed. There's 3 colors, and they have to identify and report that pattern. Another pattern recognition and navigation one was the docking challenge. So we had black and white shapes, black shapes on a white background, and the teams had to identify the correct shape, and then go dock in the correct docking bays, and to show that they could combine a couple of the challenges, a couple of the tasks together. And then the other one was a detect, classify an object as well as the navigation control. So not only are you trying to find a navigation, the correct gates to go through, we had 4 standard navigation buoys, red, white, and green, 2 of the white ones, and you can see those up here. And there were entrance and exit gates for an obstacle field. So you had to enter, we would give them, it would be a random choice of which gate they had to enter, which gate they had to leave, and then they would have to navigate through the obstacle field in order to get to the other side. So those are the basic capabilities we were looking at for the systems to be able to demonstrate and to show. And for this, it was a very sequential challenge. They could do any of the challenges, but if they skipped one of them, they were lined up in a sequential pattern. As Kelly mentioned before, we had a very tight space, so we had them the challenges very tightly organized. But they could go forward, they could skip one, but they couldn't come back to that one. So that's something that was very different. It's what we have done in Roboboat for years. It's something that we just kind of went with because we knew it was a proven situation. We were trying to scale the competition up. In 2016, we made a little bit of a change. So we added some other challenges. We added 2 strictly underwater challenges that would require either, some ability to perceive underwater. But I'll come to those in a minute. The first challenge we had for the navigation control, rather than being a part of the competition course itself, it was now outside of the competition courses, and it was almost it was essentially a way to get into the competition course. So you've got to demonstrate that every time you go in the water from the shore, when you deploy from the ramp, you had to prove that you hadn't changed anything, you hadn't lost the command and control, you could still control the vessel in an autonomous fashion. So it had to autonomously navigate the gates again, and then it could go on to the competition course. And what we did there was we had the challenges all set up as separate stations, and teams would qualify on individual challenges, right? So we have the detect and classify object with navigation and control. It's still an obstacle avoidance challenge. However, we've added a little bit of complexity to it. So it's evolved from the basic obstacle avoidance to one where you avoid obstacles and you got to locate something and circle it. So you're balancing avoidance with seeking an object. Similar almost to maybe a search and rescue mission through a debris field, for example, where you've got to go in and find something while avoiding everything else. The docking challenge remained very similar. It's one of the pieces that evolved a little bit. It evolved from black and white signs to white signs with colored shapes. So we had red, green, blue shapes. What they did was that added a level of perception requirement. Not a big one, but you gave us that, and you had to dock in 2 bays instead of just 1. So it added a little bit of complexity as we went. Again, we're evolving the challenges a little bit. The color perception was basically the same. The difference was how it was used later, and so I'll come to that in a minute. And then we had a new challenge. We wanted to add a mechanical actuation challenge. And so for that, use the same colored shapes that we had for the docking station. So a lot of the same software, a lot of the same perception algorithms can be used. Now you've got to launch, we used a blue racquetball, so it was fairly common across the world that anyone could get. Launch that into the target area, and we gave bonus points for getting into the smaller target. And then we changed the entrance and exit gate a little bit. We combined that with the beacon, the acoustic pingers. And so whichever was the active pinger in that area would tell you which gate you needed to go through. So if this one was active, it would have to enter and exit through that one, but it had to circle the other buoy in order to get through, to go out, around, and back in. So that was the challenge. Again, it's a navigation along with some underwater localization and recognizing the buoys. And then we added 2 underwater challenges. One of them modeled lightly off of the one from RoboSub with the orange path markers that are at RoboSub as a way to kind of connect the 2 events and kind of show some of this reuse of some of the same tools and algorithms. And the difference is you had to follow the orange markers, look for the yellow ones that were the brake markers, and report what was in between those 2 yellow ones. So you had to kind of take it and go a different direction with it. And then the other one was an underwater shape identification challenge, where we had shapes in different quadrants of a field, and the system had to go down, and these were placed on the seafloor, all these objects. So the theory was that you need some kind of offboard sensing or some kind of remote sensing underwater to be able to perceive these shapes and colors to be able to do it. Visibility was not great. We knew that, and so that was a challenge to encourage teams to go. We're hoping a little bit, kind of our philosophy here was we were hoping they would build unmanned underwater vehicles to go in and seek those. A lot of teams also tried cameras on poles from the vehicle. So it was one of the things we were curious to see how they would solve that. The other big change we had in 2016 was rather than run it as a sequential challenge with all the things, the challenges were, the teams attempted the challenges individually and earned points on each one separately, almost like stations that they would earn points on individually. And once a team had earned points on 5 of the 7 challenges, they could go in and essentially graduate to a competition course where all those were active and ready to go, and they'd have to put those pieces together. For example, the color that you perceive on the light buoy. The first 2 colors would tell you which 2 colors to go dock at. Or you combine that with what the underwater shape detected was. If you detect the underwater shape in a certain area, you combine that with the color you detect on the light buoy, and that tells you what colored shape to go do. So there were additional points if you were able to combine those and learn from the different tasks and bring them together in a more intelligent way. That was the philosophy we went with there, which is a little bit different than what we've done in the past. So that was and we're hoping to take that forward and do more and more of that in RobotX as we go further. So that's one of the big pivots we worked on. And with that, I will turn over to Hayato for some discussion on the Japanese competitions.
All right. Anyway, next. So, all right. So this is what I showed in this morning. So this is a convention. Actually, there's the AUV competition inside. That is competition. And then there's a freestyle demonstration because we don't like to eliminate the newcomers or beginners. Always we want to welcome them together. That's why even the beginners level can join in the same field. That's why we have 2 categories. And also junior, we bring the junior high school and senior high school together so that they can learn what the college students are doing. And even students can do mentoring to the junior high school students. That we are doing at the same site. We usually do 3 days. We cannot do 1 week, but we just do 3 days. And then there's the not only a competition, but we let them prepare some 1-page document, what technology you want to emphasize, not a full paper, just 1 document. And then I also have some presentation in this room, and we score these documents and the presentations and the competitions. So how we score it. From the start, there's a 2 bar and go straight. And then usually we change slightly every year because some students finding some good way to escape the rules, right? So that's why. So to find the red line and follow the red lines and go through the gate, and then you can touch the 2 types of the buoys and in the different depths. And then there's a crab that you can touch it, and you can have some special award. And then finally you can land on the table. So this is because one fishery companies are helping us. They are operating the research vessel of the drumstick. So they provide us the crab can. And they gave this one, so we set the Golden Crab Award. So touch the crab, get the prize, catch me if you can. Right. So we want, as I want to show this one is our very important point is we want to gather many people. That's why we don't like to restrict the top level person only can join it. So the top level, entry level person and top level person in the same competition. That's why we give our touching buoy, you can try it, just focus on the touching the buoy, or doing everything autonomously. So we give the additional points for that one, if you can do it, everything autonomous. And then I usually give them different colors and different depth. And the gate passing, so there's the vertical bars, so you do not need to control the depth. Or some team can use tether cable with like some buoys on it and can control it. But we, if they use the remote control, we reduce the points like that. And then the passing the ring, so you should have a precise depth control, and you cannot have tether cable. And then landing, So about measuring how they do autonomously, or software is properly functioning or not. So they're landing on the table and then stay there for several seconds. Do not move. That means the software is properly functioning, right? And then this is a child vehicle that I showed you. And then, okay, this is already already finished. So this is what I shared. Thank you very much.
For those of you who don't know me, my name is Dave. I'm the technical director for RoboSub. RoboSub's been going on now for 20 years, and I've been involved with RoboSub for 20 years. I was a competitor for the first 4 years, and then I became technical director. So I have a nice perspective from both sides of the fence. That's what you're talking about. So obviously, when you're dealing with a competition, the venue is most important because you need to try to fit all of your tasks within the venue. And over the 20 years, RoboSub has been in 4 different venues. We started in Panama City, Florida. The star represents the launch point, and then you can kind of see the width of the pond that we were in. There were 4 teams the first year, and around the perimeter of this pond were gates. They were essentially about 10 feet in length, about 3 meters, and you needed to pass through all 6 gates. So basically, you're following the perimeter of the pool. Nobody did that the first year. So then the 3rd year, we moved to Disney Colorado Springs in Florida. Again, the venues are all fairly similar in size. This one's more, first one was man-made. This one is more natural-ish. The water clarity in both, actually the water clarity in all of the venues have been really bad. Next year we moved to the Naval Academy. This particular year we actually lost a vehicle. The water clarity in this one was really, really bad. At the time, when I was a competitor for this one as well, we had a bright orange vehicle. About 3 feet underwater, it completely disappeared. And so during one of the events, one of the vehicles just submerged, and we always have a diver in the water to make sure that they put hands on it and to retrieve the vehicle. And it just submerged so fast that the diver lost it. And we spent 10 minutes looking for it and just could not find it. So it sat. A week later, they brought another vehicle with a side-scanning sonar out to look for it, and it turned out that it was right at the dock. It just dropped all the way down to the bottom. And finally, we moved to Transtech in 2002, and we've been there ever since. It's a nice venue. The bridge actually has no pylons in the water, so it's completely open. Over the years, we've gone from using the 2 halves, so the bridge basically bisects it into left and right. We've gone from using left and right into quarters, and so now we actually use all 4 quarters and stuff the course into all 4 quarters to try to give the teams as much time in the water as possible. This kind of breaks down the changes that I make or the changes that have been made over the years. As the competition goes, I try to evaluate how teams do, what they do, what they accomplish, what I think they can do, and then I try to make small changes to that as we go, and also introduce new things. Robotics is a multidisciplinary endeavor, encompassing mechanicals, electricals, and computer scientists. So I try to keep it interesting for all 3 of them. And so over the years, we started to include, there's the pinger that came up in 2000. We've been using that ever since. Topography and barcodes are more visual based, as well as light detection. We got the marker drop, so we started including dropping things. So again, we incorporated another mechanical task into that. Surfacing up in an octagon. Line following docking lights are no more visual stuff.
let's see, 2009 we did torpedoes. So that introduced yet another mechanical challenge, another mechanical aspect of it. So, and then touching multiple buoys, and then there's manipulation tasks. So vehicles now usually have markers that they drop, torpedoes that they shoot, and some form of gripper either on the front or down below to pick stuff up, retrieve them, and move them around. So I told you about the first year, which was basically the pond with 6 gates. This is what we did for 2007. Focused just on 2017. What did I say? 2007. Sorry, 2017. That's not what I want to do. There it is. All right. Focus just in this A quadrant. Again, the gate is the same gate that we used in the very first competition. So we took that element and incorporated it into all of our future competitions. The gate provides a way to visually see that a vehicle can maintain a depth and maintain a heading, which actually is pretty difficult for an underwater vehicle. And from there, they move into 3 different colored buoys, and they need to touch red then green in order to get the most points for that particular task. We have path segments, which is these little orange things. So from the gate to the buoys, the path segment more or less points to the red, and after the buoys, the path segment more or less points to the navigate pass in this case. Navigate pass is sort of an inverted gate, so it's goalposts for anyone, for American football, or the letter U. And so the idea was you have to pass through the goalposts. And last year and this year, we gave them points for going through with style. So anytime they changed 90 degrees in direction, they got multipliers. So if you went through backwards, that's 180, so that's a 2 times multiplier. So we started to have teams that would do barrel rolls or start rotate back and forth. So we did have teams, it was up to 8 changes in direction. So we did have teams who would do like 2 barrel rolls going through the gate, or 2 rotations as they go through the gate. That's the last task that's actually visually marked. These last 2 tasks use pingers, and only one of them in a quadrant is active at a time. Teams can recommend or can request a random pinger, in which case the vehicle must identify where it is and which task it's on and complete a task. Or they can request which pinger to turn on. So going over here, in this particular section, which in this case is cultivate pearls and battle squid, there are 2 bins represented by these 2 guys, and this is where they drop markers. One of them actually has a cover on top of it, bright orange cover with a handle. And so to get the most points, you have to go pick the cover off and then drop markers in the bin that was previously covered, and you get 2 markers. This guy, which you can't really see very much, that's where the torpedoes are. So it's a horizontal window. In this case, it's a vision of a squid. The theme for this year was 20 years under the sea, in reference to 20 leagues under the sea, 20,000 leagues under the sea. And so there were circular cutouts in 2 different sizes. And so you got the most points if you fired torpedoes through the smaller of the 2 openings. And finally, over in this task, again, the green represents pingers. So the pingers is located on this octagon, which is floating on the surface. So you get points for surfacing in the octagon. You get points also located on top of the pinger is this tower, which has these 4 different samples on it: red, green, blue, and orange. Blue and orange are smaller than the red and green. And so this is a complicated manipulation challenge. So you get the most points if you took the green one and dropped it on a table. So there's a little table here, and there are 4 different ovals with the 4 different colors. And so if you dropped the correct PVC structure onto the oval, you got the most points. And for 2017, we had 44 teams, international teams, and in the finals we had 7 teams representing 5 different countries. So it was kind of a nice finals. In general, my philosophy, which is apparently a lot of people's philosophies, There's a balance. You don't want to scare away new teams, but you want to keep it interesting for teams who've been there before. And so you try to incorporate easy tasks for teams who are just coming in. So in my case, it's going through the gate and touching buoys. And then you also try to make it interesting for teams who've been here before. And so that's all the other stuff. I always release a preliminary set of rules, which have basically guidelines, and then there's questions. So I try to elicit feedback from the students. So they actually help drive the competition. It also keeps them, it keeps them from complaining less because they actually pick the colors and the sizes. And then obviously I like to keep it fun. So in 2007, I started doing themes for the competitions. X marks the spot because 2007 was the 10th competition. So that was a pirate theme because 10 in Roman numerals is X. So I did a pirate theme, Underseas 11, Diving Dozen. Underwater the 13th, Friday the 13th theme. Robo Love, that was a Valentine's Day, 14th, February 14th. Ides of Transdeck is Ides of March, March 15th. License to Dive, because a lot of children in the United States start learning to drive when they're 16. Transdeck 17 refers to a mission to the moon. A Pirate's Life for Thee is just because I want another Pirates theme. And then finally 20 Years Under the Sea, which was 20,000 Leagues Under the Sea. For me, I like the themes because it helps unify all of the task elements, and the students seem to enjoy it as well.
Well, my task now is hard after all these presentations, but I hope I won't disappoint you, hopefully. So my name is Fausto Ferreira. I'm representing here the European competitions. We had several ones in the last years, and I'll try to first distinguish what is what to help you understanding. So you know that normally you have student competitions or the Grand Challenge style, like the DARPA Robotics Challenge, probably you know it from the US, or the MZIRC Challenge recently also. Our positioning as student competition is, of course, inside student competitions. SOSI, which stands for the Student Autonomous Underwater Vehicle Challenge Europe, has been organized since 2006, first by the STL in the UK, then in France for a bit, and then from 2010 at CMARI in our water base in La Spezia, Italy. First by the technical direction of Dr. Vladimir Diapic, which is now in the other section, unfortunately. And since 2014, is there? I thought it was in the student poster session. And since 2014, by myself and Dr. Gabriel Ferri, which is also in the audience. Some people consider us the most realistic underwater robotic competition in the world. It was not us. We read this written by some folks from Singapore. So I'm not stating myself this. So it's dedicated to students. Then later, we got into this European project to extend this for multi-domain competitions. And that's Euratom 2015 Grand Challenge. It's called the Grand Challenge, but it's still between Grand Challenges and student competitions because it's open for students. Mostly we have student teams. It's also open for industry and companies, and we had some mixed teams, but it's still in between. We want to keep open to everyone at the same time and also balance to a more professional level, let's say. It was the first world's robotics competition for multi-domain, meaning land, air, and sea. And it had its second iteration in 2017 with the European Robotics League Emergency Robots. This will continue under this umbrella for the next 4 years as the European Robotics League. So SOSI in itself, these were similar both in 14 and 16. This is the arena that we have more or less. It's quite similar to what we already saw from other competitions. So we have a starting point here, and there's a navigation task going up to here. I forgot, there should be a gate over here. So it's similar to what you have also in RobotX. They don't manage to do anything else until they pass the gate. So that's qualificatory. And then you have 5 different tasks that can be done separately, but you have double points if you combine them all together. So we have a black box search, which is also a pinger, but we put it in a black box like airplane style. In 2016, we had an area where there's a mannequin, because this was inspired in search and rescue robotics by then. We have an underwater structure, basically it's a piping structure that they need to inspect, circle around and produce a map of it. Then we have wall falling and searching for an anomaly, which is a buoy with a light on it. In this particular task, we introduced a collaborative task between AUVs and SVs, which means that they can have a vehicle underwater, one in the surface, and this can even be between two different teams. So both teams score, one for the underwater, one for the surface vehicle. And since our experience, there was not much luck with this in the last years, but I believe 1 year there was a team that managed to do it. Vladi can probably say more about that. So as I said, this is basically just for students. There's no companies involved as competitors. We also try to balance between new entries and older entries. We have a second arena replicating this one just next to it. So even teams that are not ready to compete can try their vehicles in the water. We have 2 pools on the side with salted water to let them try. And normally we push everyone to go to the water even if they are not really ready, even just to try the last day, a bit. And we managed to convince almost all the teams to actually do something and try it in the water. Some teams come and they learn that you need spares for a competition. Some others come and do everything in a second, so it depends a lot on which teams you have. Then through this experience, in 2000, actually it started in 2013, but the multi-domain competition was in 2015. We had Erasmus Grand Challenge. This is also in a open water, let's say, and basically we also have 2 arenas. It's pretty similar to what we had before, but we don't have the black box, and we have OPI's area, which simulates a plume. So we have a leak made of 5 buoys, and they have to follow the leak. So they have to search. They don't know the pattern. They know that there's 5 buoys in that area. They have a square for search, and they need to follow this leak. Supposedly, there's also numbers that they should manage to recognize, but with low visibility, no one manages to do that. In 2017, we added debris area where the missing worker, meaning the mannequin, was trapped. So we had the mannequin already in 2015, but now we had some tables around the mannequin to make harder the task to find a bright orange mannequin, because actually that was one of maybe the most easy tasks to find, because it's almost 2 meters bright orange thing. They also have the passing the gate thing, and here I'm missing. In 2015, we had a long-range navigation coming from outside this harbor. For this year, we took it off and added this part of debris, because we saw that not many teams could do the long range and do all the field in the limit time that they have. And also, this year we added the surface of underwater robot on the top of the missing worker, and calling an aerial vehicle to come closer and take a picture. As I said, this is a multi-domain competition. I am not touching the land and the aerial part, but we do have some cooperation between the domains. This is one. The other cooperation is the underwater robot needs to inspect the piping structure over here, find a marker, and the marker here maps to a marker and to a valve inside this building for the ground robot to close, and vice versa. So they need to exchange this information. Plus, they also need to close a valve here that is, the number of the valve is given by the ground robot marker detected. So there's this vice versa, and it's pretty challenging. We also have 2 arenas, one for testing, one for practicing, and it's always a challenge to balance how many teams you have and how many you can put on the water with enough time. So we do limit also the entries through an application process with a paper, so not everyone can come. We welcome new entries and less good teams. We had several teams that came first year, they were not good. After 3 years now, they did an awesome performance. But it's always a challenge to give time to less good teams, and at the same time manage to have a high level competition, or let other teams actually do something useful. And I think that's pretty much it. So now I think it's time for a discussion. That's it. Thank you.
So now I'll invite the 4 panelists up to the front here, and I will kick off the discussion here by invoking my prerogative as the panel moderator to ask the first question, which is for each of the panelists. What's the main goal of your competition in your eyes as the technical directors? We all know there's lots of positive things that come out of these competitions. We're giving people educational experience they can't get in the classroom. We're priming the pipeline for industry. Potentially, we're advancing the technology involved and the algorithms involved in autonomy. So what's the most important thing for you? And can you give an example of a design element in your competition that has been chosen specifically to advance that goal?
Okay. So, So for RobotX, it's actually twofold. It is the big product is really the students, the experience for the students, and developing, as Kelly said earlier, a larger pool of people who can contribute to the autonomous maritime systems world. The other part of it is I always try to tie it to something in the real world. I try to connect it to something that's a real world mission, maybe search and rescue, or the autonomous docking is an obvious one, it's like a self-driving car. Same types of, a lot of the same types of behaviors, just in a different environment. So it's kind of a intertwined approach to get the students built up and maybe solve some problems we struggle with in the unmanned systems world.
So main goal might be how to say, because there are many robot competitions in Japan, but underwater, especially a very small group. So every how to say broadcasting program can deal with the robot competitions, but underwater robot not so much familiar. So we want the nation to realize that underwater or ocean or maritime robot is also very interesting, and also we want to promote the ocean itself is very important for the human beings. That is how the ultimate goal of our competition.
Just like everybody else. Ditto. We try to foster, student interactivity, giving students experience in the real world. Competitions always do that. Underwater and surface are a budgeting industry for robotics, and so it sort of gets the students thinking about working in underwater or surface vehicles. So for me, that's kind of what the competition's about.
So in our case, I think we have 2 different goals for each competition. For SOCI is more for student-based and training, even systems engineering, let's say, to try to actually assemble a vehicle and put it in the water and work. While in Aeroathlon, we want to push the state of the art to advance. We saw several examples of innovation through the competitions. And for Aeroathlon, we were loaning standard platforms to teams so they can focus on the algorithms and on the platform itself, which then gives results like one team that got a loaned platform 2 years later came back with their own built vehicle. So they learned enough, know how to then produce their own vehicle. So I think in the second case, we want really to push the state of the art and connect it to other domains.
And now I'll open it up to the floor for questions from you guys. You have some of our greatest maritime competition organizers here on the stage, so fire away. Mal.
Yeah, thanks. To what extent do you think it's a public awareness, a cultural thing? We've got 70% of the Earth's surface is ocean, and it's unknown, underdeveloped, underutilized, all those things. So to what extent is this an overriding umbrella that by doing what we're doing is actually informing everyone that there's an ocean out there and there are challenges to be met, and all of the students in the world who are not participating in these competitions might be inspired a little bit to get into that area. So to what extent do you think we should be aiming wider like that?
So we try to do that and to raise public awareness by doing it in a public space open to everyone, and do special parallel program to the general public, doing tours around the competition, and even doing activities just for children and young students. At the same time, we brought our high school team, although this was mostly for undergraduate and graduate in the aerial emergency, and doing it as search and rescue and actually Fukushima inspired. I think we're already doing that in that sense, because the application in itself is already explaining that we need to protect our planet and our oceans, basically.
I think with the loss of Jacques Cousteau's Undersea World, this is the next best thing for people who know that. It is difficult just to try to get awareness. Like you said, the ocean does cover a lot, and we don't know a whole lot about the ocean. And so hopefully this does foster more people to think about what they're doing to the ocean.
Maybe I cannot properly understand your question, but maybe we try to invite the local governors, especially if we do in Yokosuka. There's the Yokosuka Navy base and also Japanese defense base there. And their politicians also very much interested in what we are doing there. So we, try to expand that ordinary people realize that this is interesting, and then, is it correct answer? I'm not sure, but yeah, we are doing that way.
So I think events that we've seen in the news help kind of bring up the importance of understanding what's down there, the loss of the Argentine sub, and the Malaysian Air flights, and it was the unmanned systems going down there and doing the searches and looking for that. That helps kind of bring some public awareness to the need for this in some ways. I know I think we've all to some extent looked at how do we design challenges that kind of use some of those elements, the search and rescue, the underwater, the underwater, looking for underwater shapes and finding things and recovering them. Those all have aspects of that involved. The underwater samples is a good example, and then traveling through and landing on the platform, things like that. There's all things you might need to do, and those are all connected to things you might do in the ocean. I think we could always do better at kind of expressing that, hey, this is how it connects and this is how it really goes out there and does something. For RobotX last year, we incorporated a lot of Hawaiian themes and a lot of the cultural themes in there to try and bring that in and show, hey, we are connected, this is how it would help you, this is how it can be used. And so I think that's sort of, I think what you're asking is how do we show that and bring that connection to something that the local community is interested in, I think really helps.
So one of the goals, it seemed like across all the competitions, is getting a good experience for the students, a real-world experience for the students. And I think that's a very subjective, challenging thing to measure. And so I'd like to hear your thoughts on, or what thoughts there are on how do you measure that and ensure that is happening.
So for RobotX, we have tried to be very active on that and we have an online forum in which we discuss and try and get some information out there and then request feedback. It's one that we're working on improving, and so the biggest thing for me, I think, is to make sure that we are open to receiving the feedback from the students. It's why we have the feedback session happening, is to kind of really get some input and understand what are we meeting their needs? Are we doing what they want? The other balance to that, I think, is the industry participation, right? So connecting with industry, connecting students with industry, understanding what they need and what the students can get from it. A lot of the students want to go out and get jobs. So how do we build that connection? So I guess the short answer is we ask. But we try to find ways to connect with them and interact.
I'm sorry. Yeah. There's a thing that through their experience are not just winning something, but that they try hard and meet very difficult things or make it perfect in the laboratory and put into the field, and then it totally fails. Such kind of experience let them have a very nice experience, and then finally they have a real, they did by themselves, overcome by themselves, and that they can put, for example, writing their CV or some application sheet for the company, and they can, from their own words, they can promote by themselves. That time we could see, oh, this guy has really have a good experience. That is a very good one that I saw from some students in the competition.
Similar to X, we also do an after competition forum to evaluate or to get the evaluation from students. But as Aamir said, asking during the competition is one thing, but just witnessing what they do. When you see a group of students and they're all cheering because their vehicle goes through the gate, you don't get that after a math test. Even if you do well on the math test, you don't get that excited about accomplishing something. And so usually it's a visual indication. It's usually a very simple visual indication of how the students are enjoying what they're doing.
Yeah, so we have a similar thing. After each competition, we ask them feedback, and we got sometimes long list of emails saying, you should change this, you should change this, that, whatever. And we take this into account for the next year competition normally. We even adjust the tasks to the competition. And when we publish the rules, as you have also, we ask feedback from the teams to actually shape the rules for the future. And even during competition, we might be flexible and adapt to the students' needs. Plus, we have involvement with industry. We were giving an internship for the best students some years ago. And I think the best measure that we can have is how many students come back and do it again year after year. We had teams that left, they couldn't participate in 1 year, and then 2 years later they came back. Or even other teams participated as undergrad, and 5 years later, they were the grad students managing the team, and they came back because they managed to raise critical mass. And in our experience, every year we have teams that keep coming back. We have some new entries. Some drop out sometimes, but they come back after 2 or 3 years. So I think that's the best way we can measure, actually.
Actually, I have something else to add. And it's just because of the history. Because RoboSub's been going on for so long, a couple of years ago, we actually had a group of students. RoboSub is interesting in that it's supposed to be collegiate competition, but we also get high school, and we've recently started to get middle school students. We've had a high school team who's been there, a long-standing high school team, and just recently, a couple of years ago, we've had competitors who were in high school. They graduated from high school, graduated from college, got a job, and they all came back and they actually donated money to their own high school to help continue participation in the competition.
I have a question. I think most of the competitions emphasize the involvement of the government, the industry a lot. So can you share your experience on how to build up the link with the industries?
That's a shared question. If you can tell us, we will appreciate. No, it depends. I mean, it takes a lot of effort, marketing effort, basically, and personal contacts effort, and going to conference forums, speak with the industry, contact everyone that we know and that works in industry, and sometimes what we saw is they come first year to see the competition and they get more involved because they like it. But it's a really hard task, and sometimes if the students don't actually profit from it, the industries might turn away. Like we were offering discounts from some brand, and then no one was using that. That company might not want to participate again or sponsor again because the students didn't care about that particular thing. So it's really hard, I would say.
I agree. Actually, Sherry, did you want to answer that?
I can only add that RoboSub, I'll tell you that RoboSub is one of the longest standing competitions, and from my perspective, if you want to beat the best of the best in underwater autonomous vehicles, you will come to RoboSub. And when we get to go to companies and we try to sell that, that's what they're looking for. They want the best of the best. Even then, it's a very difficult challenge. For teams, I would encourage you to talk to Hitesh. At Embry-Riddle, he was very successful in going out and bringing in money, sponsorships, and selling what his team did to industry. The other thing is we do encourage teams. You guys look at it from a technical perspective. You get the electrical engineers and the mechanical engineers and the computer programmers on board, but you forget that some of you use this as a capstone project. There are marketing majors at your universities who would love to use your team as a marketing project. Send them out there. So you have to look beyond what your normal disciplines are and bring those business majors in, bring those marketing majors in and say, hey, you know, we need help, and this would be a good project for you to come and help us raise money. So.
Yeah, I can say in Japan, especially very difficult. You know, not so much marine industries are there. There are the marine industries, but not like major oils or defense. We do not have. So just they bring their items to promote, like show some of their items to the students. That is the beginning. And then sometimes we ask companies to bring the underwater cameras or like that support was the beginning. But recently we could see that big companies want engineers. So I hope students grow up and then get into that industries will be some help for the future.
So I think I actually at lunch I was talking with a few folks about this. One of the big things that I see, you can go out, you can ask for sponsorship, you can ask for donations, but the other thing you can ask for is mentorship. So if you reach out to a company and say, hey, do you have an engineer who's willing to help? We're having this trouble with this technology that's in your field. Do you have someone who's willing to help? Are you willing to contribute a little bit of that person's time, or are they willing to volunteer? That's a way to kind of get a connection with someone in a company. And you can build that. Maybe this person goes back and says, hey, these guys are doing really good work. We should help them, right? That's another way in. Like Sherry said, reach out to the other parts of the universities and get help. I remember, I think it was McGill a couple years ago, came in, and I think they were the first year team to make the finals, if I remember correctly, at Sub. They came in and they made the finals. They came in with a brand. I mean, I think in my backpack I probably still have a McGill pen. They were giving out pens, sunglasses, all this stuff, and they had everybody at RoboSub talking to them, including the industry people, saying, hey, you guys really went and did a really good job of marketing and building this, and we want to talk to you, right? So that works also. But for me, the biggest thing I think is looking for a mentor, someone in that field who's already doing that work, who's willing to work with you and kind of give you technical assistance. And advice. I think that's a good way to build a relationship and build a trust between the company and the team.
So related to this, I think it's a very good idea, and I think that works very well. We saw that in companies that were actually participating before as students. So we had, I won't make names of companies, I don't want to promote anyone, but we had companies where 2 or 3 people were students by then when they participated in competition, and now they understand better and they come as judges, or they come back just to see the competition. They try to mentor and help even their university teams that live in the same city. They manage to sponsor or give guidance to come to the competition. So basically, I think the best ambassadors are you when you graduate and you work in companies.
Let me just say one more thing. I know that RoboNation is working on a LinkedIn project to, so instead of collecting resumes from all of our students, we're asking our students to join LinkedIn and try to link you together, because ultimately your goal is to get a job. And for some reason, it has been difficult for us to sell the resume, sell that, hey, we've got all these great students and we want you to come and we want you to see our students. For some reason, industry has had a hard time thinking that that's valuable. I don't understand that because you want engineers. I've got 50 teams worth of budding engineers who are going to graduate in a couple of years. Why are you not coming to see these guys and girls as they work? But we're trying to work through LinkedIn to make it easier for our companies to see the value of having 400 technical students. And you can now look at their LinkedIn because we're going electronic in this world. So it is another way that we, anyway, are trying to help you connect with industry. So.
Yeah, I'd just like to add as well, we've mostly focused in this presentation on the performance and competition design of the challenges themselves and the tasks. But most, if not all, of these competitions also have a static judging component that involve a research paper, a presentation, and so on. And I've observed that those having to do those things helps prepare the students for not just interviews and things like that down the track, but also their fundraising. I've seen students send out their research papers that they've written for the competition to potential sponsors or potential donators of equipment. They've sent out their technical models, CAD designs, and stuff like that. And it's given them more confidence and more sort of experience in putting forward a professional presentation that can help them raise money or get donations of equipment and stuff like that. I don't know if you guys want to say anything about that static judging aspect.
Actually, that's a really good point. The static judging, the onshore judging, the presentations and the papers are something we have tried to model off of existing standards and tried to build them into something that could help prepare you for that. So there's a conscious effort to do that. To really make it clear that if you can't communicate your ideas, you can't sell your ideas, you can't get support. If you have a really good idea, but you need help to build it and you can't communicate it, you're not going to have it done. So that's one of the big things we design into the competitions as well, is to encourage that level of thinking that, hey, don't forget about the communication aspect. That's something that's, I know a lot of engineers, we tend to forget.
Yeah. For university level student and the senior high school student level, we do together. So we cannot ask senior high school level student to do good presentation and good papers. That's why we decided to use just a simple resume or like one page of the documents, but should have the how to say, the robot information and what is the key point of your technology should be in there that we judge. And good thing is that the high school student can sit together and watch that how university students are doing, so as to let them study in the same place. That is a good thing. Yeah.
I like a lot of what you guys are doing, by the way, and I love the freestyle thinking for starters. I think it's great. And about just it was a suggestion more than anything, and it just occurred to me based on what Shay said. I was involved with the MATE competition from the get-go and introduced the presentations and so forth. I just realized something sitting here. We had them do that as an educational tool to give them some skills. We never had anybody give them feedback about how good or bad it was. We didn't have a professional in the audience. I don't know if you can do this and incorporate it somehow, but if you can get the marketing guys to just come in and give them tutelage when they do those things, or somebody else that knows presentations really well, that might be a really nice tool to attract people also. Just a thought. I hadn't even thought about it in previous, but that'd be something that would be for an engineering student. It's like, oh, I can get somebody to teach me something so I can get a job. I had one other thing, and I don't know if anybody does this yet, in terms of building a competition and thinking about safety. I've seen the complexity of the vehicles go up and so forth, and actually the scariest moment I've had was in Piombino. So the water was dark, we lost a vehicle. It made the competition very late, trying to find it, and then we pulled it up. It was the water had gotten to the batteries, and it was pretty scary. And of course, everybody came running around to look and see what was going on. You could smell it burning. So it turned out not to be so bad. The design was not unsafe particularly, but the timing, I thought, and some things like that about keeping things on schedule. Do you guys have pathways to, because that now it's becoming a deal because you're getting very complex. I mean, some of these things are getting to be pretty intense in time, and you only have so many hours in a day, and you're getting more teams. Just asking.
Well, yeah, I mean, obviously safety, we try to build safety in, but we have humans involved. And similar, we had a couple of incidents as well, one with a battery, one with torpedoes. And we try to learn from those and build in more safety, but we also try not to hamper it as much. We try to do safety intelligently. And so yeah, we have stations of buckets full of sand. So if a LiPo is puffy, we take the LiPo out and we'll stick it over in the sand, which is far away from everybody else, and make sure nothing bad happens. And similar with the torpedo incident, we now make sure that nobody has loaded torpedoes in the tent, that they can only be fired when they're in the water.
So yeah, we had that incident this year. We had in the past some vehicles sinking, but no one ever had anything with batteries. We normally try to have safety by design, meaning we do a safety inspection of each vehicle before going to the water and check if they respect some features that we precisely define or not. And we had several vehicles that were like failed, and we said, no, you're not ready to go to the water. Your vehicle is unsafe. For instance, just emergency stop that will be easily accessible by a diver without cutting their hands on the propellers. And some team had it really close to the propellers. We said, no, this is too dangerous. You're not putting your vehicle in the water. And we had, of course, fire extinguishers, everything, safety expert, etc. But we'll learn for this year experience, and we'll try to improve for next year's for sure.
Along the lines of what they both said, we design safety in as much as possible, again, to minimize the impact of innovation. So it's a balancing act. Battery safety, the teams are required to submit their battery safety, their plan. The kill switches, the first year at RobotX, we were a little more open with the kill switch design. The second year, we said this is how it has to work, and we gave a very specific diagram on how it had to work. So we did learn from that, and there's always still things that can come up. You can't know what you don't know, as Kelly said this morning. But yeah, so we do try to build that in and balance that with innovation and with giving the teams enough free rein to try something new.
Yeah, we do the same thing that the small tank we prepare, and all the oil leaking is nothing. Or some newcomers, we do not restrict the tether cable. Before one student, newcomers, they put the big cable using the alternate current. And then we have a support diver inside. So, okay, let the diver go out, but Jumpstack said, this pool is very safe. Even if you drop the alternate current, the diver will never die. So, okay, so let's continue. Just a story.
Okay, I have a question here. How do you ensure a level playing ground for teams where English is not their first language? Because I observe a lot of competition that those teams from China, from Japan, from Korea, I think they suffer when they come to presentation, in their oral presentation, even written presentation. I think it's not fair to them if they compete against the States, the Australian type of presentation.
For us, it's Europe, so there's no official language. English is second language for everyone except for the British. So.
Yeah, language problem. Even for me to sit here is always very difficult for me to understand the question properly. Sometimes I worry about what I'm talking is very wrong way. So for Japanese, it's really hard to write English paper for especially high school students. It's very hard. So maybe I should think something that we need we collect some Japanese paper and then bring it to the committee to translate and then send them all to, like for example, how to proofreading things. That might be a very good help. Yeah.
No, out of jokes, now just a practical example. We had this year a high school team from Italy, and of course, not all of them were very good at English, so they actually invited the school for language, technical school for languages, to come and help them with translation and communication with other teams and with the judges. So that was an example of how to improve the team communication, let's say. And everyone else, their main language is not English, so we are almost fair except for the UK, let's say.
So I know for RobotX, one of the things we did is part of our search for the support team, the support staff we had, as well as for the judging, we did look for people with additional language skills. That was one of the things on our list that we were looking for. It's not always easy to find, and you're right. There's always an inherent advantage in the native English speakers. It's also the majority of the people we've had judging have been English speakers, so we've gone with that. But it's always a challenge. We do our best. We had this year someone, fortunately, in Hawaii who was able to translate very well for one of the teams and help to understand and bridge that gap. But that's a challenge I think we face in general in the international community as we start to bridge these gaps. Things like this, it's a tough challenge.
I think for RoboSub, at least, I don't know about RobotX, there's been an effort to kind of streamline the paper process and provide a more comprehensive template for the teams, right? So that, well, also all the old journal papers from previous years are online on the RoboNation site, but I think there's been an effort to sort of make it easier for people to approach the paper, because for many non-English speaking teams, I think the paper is the scariest thing, maybe the presentation as well, but the paper is pretty scary. And so I think this template, do you have a sense of whether it's helped, Dave?
We've only just recently started it, so I can't really say for sure. I mean, it is a good question. RoboSub started more or less, everything was English. It's only, not recently, but over time we've grew to be more international, so I think we do need to start addressing that better, and I think the template will help. But to expand on your question, that general thought actually expands to a lot of different things. We have a lot of new teams that say, how can we compete against a team that's been here for 10 years? Or how can we compete against a team that has more money than us? And honestly, the more time you get in the water, the better you'll do, no matter what kind of vehicle you've had. We had in the third year of RoboSub, I don't know if you guys remember, but the Lego brick, it's a small little microcontroller that was built into a Lego. That vehicle won that year because they had the most time in the water. So actually, it was actually a very impressive vehicle because the RoboBricks programmed with infrared, and they actually had a clear PVC tube as their body. So they never actually had to break the seals to reprogram it. They could just hold it up and reprogram it. It was actually awesome. But international speaking is a problem, and in general, competing new teams against old teams is a problem, and competing with teams that have more money is a perceived problem, and in some ways it is a problem, and in some ways it's not, because there's ingenuity, time, that all trump everything. A team may get a new sensor, which is a very nice sensor, but it may be difficult for them to integrate it. That's one more sensor they now have to integrate into their system that they have to decide if they're going to trust or not. So it's not a magic bullet.
Yeah, I have a question. What kind of thought goes into engaging the spectators? You know, it's not a spectator sport, but you know, for example, for underwater vehicles, you know, you need to know how the vehicles are doing. Even for the surface vehicles, once the vehicles are further away, you have no idea what's going on. Now you could have a big screen, and we were talking about earlier in the lunchtime that on some of the sports ground they have these cameras on wire that go down, and then you can kind of see more details with big screens. And you know, we had a competition, a human submarine competition held off Florida one year when it began. And at that time, this was in the 90s, but they did manage to do this really good display of what was going on underwater on the beach. You know, you could see with the big screens what exactly was going on. So I just wondered how much thought goes into that.
That's a good question, and that's one that we try to address every year, and it's difficult because, like you said, a submarine competition is not really a spectator sport. As far as RoboSub goes, over the years we've done various iterations on trying to improve spectator viewing and participation, and recently we have a big jumbotron, so you can watch. We usually during some of the semifinals and definitely during the finals, we always have a diver in the water that has a camera. We usually have scissor jack, so we can get similar to using the camera on wires. We have cameras on a scissor jack, so we can get perspective from high above, and then we can switch between them. We've been lucky recently because visibility's been pretty good, but you get into some of the arenas where the vehicle disappears, and that's even a bigger problem.
Exactly, I was thinking on that. Like, we thought on putting a camera underwater, but you wouldn't see more than half 1 meter, so there was no point. But this year we actually improved it for the underwater because we had a tracking system with acoustic modems tracking the vehicles in real time. That was very good for the judges. We didn't put that on the big screen that we have for spectators because at the same time it might give advantage to teams that are running later, you know, because they say where the other guys are going. So you have to be careful also with that. It's not easy to find a way of making appealing for the public, but also making that it's fair for all teams. We had that with the ground and aerial vehicles because we had fixed cameras inside the building showing the valve closing of a team, etc. We had several cameras going around the beach and the building, but you need to make sure that you are doing that after everyone tried before, so it's fair for all competitors. So it's very tricky, definitely. And for the underwater, I think it's the hardest part.
Yeah, even if we are using a very clear water, but still we are always using the underwater fixed camera, pan and tilt camera. And also these years we are using small ROV to track the AUV, what they are doing. And then everything put together into the broadcasting, even inside the room and also on the YouTube. And then another thing is that we do not make the room silent. Always, you know, when I'm doing the MC, I always keep talking what's going on and asking to the the team. So that also about the, I don't know, is that a static scoring, but we also see how the teams are expressing during the competition. This is what's happening and what's going on. That's also we score it.
So one of the things at RoboSub that you have is the commentary, the running commentary with the team member up on the stage with Zaz. And so at RobotX, we also had one of the things we started to do. In 2014, we actually had a heartbeat message that was transmitted right at the vehicle. I'd like to bring that back in 2018 and have that as something, maybe eventually we can build that into a display. That's something that, down the road we have to see if we can look at. But essentially, it would give information about what the vehicle's doing, maybe make it more spectator friendly. One of the other things we implemented last year was a light tower. So it had to give an indication of what mode it was in, whether it was autonomous mode or remote control mode, or whether it was in the killed mode or the safe mode, safe to approach because the motors are killed. So that's one step. We were a little open with that intentionally to give teams an opportunity to see how it worked and see what they did with it. It's kind of fun. As I've talked to the teams doing it, they said, wow, this is really good feedback. Why didn't we think of this? And now they're looking at doing more and more advanced versions of that. I've already gotten emails saying, can we do this instead? So getting the students to understand that, hey, they need to give feedback to the operator, right? So one of the big challenges in unmanned systems in general is trust. How does the person around the vehicle trust that it's doing, that the car's not going to run over me when it's driving by itself, right? You see in the news every time the Google car has an accident, but you don't see the 400 accidents that happened before that with a person behind the wheel. So building that trust, so having that operator feedback to come back to the operator. We also had a requirement for a display that the students had to provide to the judge to show what they were reporting on those different challenges. And we give a very clear specification. It must be this size, this font, things like that, to give that feedback. Down the road, as it becomes more advanced, perhaps that goes onto a bigger screen. We don't have the fancy jumbotron like RoboSub, but building a way to kind of have that on the live stream, the camera can zoom in on that and have that fed out. That's also a useful thing. So building that kind of situational awareness into the feedback from the system is a big deal. And so I've been looking at it from that perspective. How do I know what's happening in that robot, right? How do I do the mind meld with that robot and figure out what's coming out? That's the big question, I think, in a lot of ways. And then I think that can be made spectator friendly. Right, that's another one for the Surface Eagle that's viable.
I had a slightly more technical question. So when you all design these competitions, you're aiming for certain technical aspects to come out and for the students to solve certain problems. If you've been to one of these competitions, you know that students are amazingly good at finding very creative solutions and every loophole that could possibly exist in your rules. How much of that do you think is a good thing, and what approaches do you take to try to limit that so that you can actually get them to solve the problems that you want them to solve?
That's a really good question. So we generally look at it from the point of view of, or at least I look at it from the point of view, when I think of challenges, I always want to have at least one part of the challenge that I don't think they'll really be able to achieve perfectly, right? I was going to push them a little further, right? Say, to say it in the simplest way, if any team completes everything perfectly, then I've done something wrong, right? There should always be something that's a little bit stretched to kind of keep them interested, keep them coming back. But also, there's going to be loopholes. There's going to be things that people find. We do our best to minimize those. Sometimes leave a few in there intentionally to see if they come up with a solution we hadn't thought of. I know we've left some openings in the past. Just kind of we'll see if they can solve something we didn't know about. It's always that balance of finding a way to express the challenge or the problem statement in such a way that we tell them what we want them to solve. We don't tell them how we want them to solve it. We don't want to tell them how we want them to solve it. We want to see what they come up with. I feel like I'm crowdsourcing solutions to problems that we have in the unmanned systems community, right? I've thought about it. I don't see a solution. I want to see what you come up with. You don't know that you can't do it, so you're going to find a way to do it differently. And then a lot of the students are more connected with some of the things that are happening and changing it, or they create something that wasn't there before. So yeah, I don't know if that goes directly in what you're looking for, but it's in the right direction, I think.
Yeah. For us, every year we are watching that how students are doing, and they always find some new way. But for me, some students find some point that they can find their way. Is also we evaluate that is a new idea for him, right? So we do not like to restrict these things, and so every year we adjust. But finding the new things, we can give them chance that make them just fun, right?
So one of the reasons why I got this job is because I was a competitor who did that. And so being on the other side of things, I actually appreciate when teams find my loopholes. Sometimes intentional, sometimes not. But yeah, as Aamir says, we're setting up tasks, and we're not trying to hem them in a solution. And so usually when I'm trying to design something, I try to make sure that there's at least two different ways of doing it, an easy way and a not so easy way.
Yeah, so of course we have the same experience. Sometimes the loopholes are to trick us, sometimes just unintentional, of course. In SOCI, the rules are more precise, and you have tasks divided by subtasks, and it says, if you find a pinger through either phones, you get these points. If you find it visual, you get these points. So in that case, it's very specific. In Eurotland, IRL emergency, it's the same, like they were saying. We tell them what to do, but not how we do it. In that case, then there's doubts. Normally teams ask us, can we do this, can we do that? And whatever we didn't thought before, because normally we think carefully what they will try to trick us here or to find a loophole here. In their competition, normally the day before we have a meeting and we try to solve all these new issues that we found out. Other times, it's fine if a team innovates and does something very weird, but it works. For instance, we had a team with a wooden stick from cleaning stick, using it as manipulator to close a valve. They didn't have a gripper; they just pushed it. Push it, push it, push it. They had a frontal camera looking at the valve, and they managed to do it. And it was allowed by the rules. We are promoting innovation to low-cost platforms, so why not?
And to build on that, actually, students capitalize on other students' solutions as well. A couple of years ago for Sub, there was something that was perceived to be a very, very difficult task. And there was one team that came with a very simple solution to it. And the next day, there was 4 or 5 teams that had the same simple solution.
So, I'd like to go back to the discussion on industry. Why can't we get industry to participate? Because I think I may be the only person from industry here. So you talk about why wouldn't an industry want to spend money on students during the competition, right? And if I have $1,000, there's absolutely value. The students that are going through these competitions are very attractive. But if I have $1,000, I want to spend it on a student when they're looking for a job. I'd rather increase their salary and compete against other companies rather than spend it on the competition. I see this as more, I don't spend on their tuition, right? I don't subsidize their tuition usually. So I want to reserve my resources to attract the student directly. That's one thing. And maybe if you think about that, maybe try to twist the value proposition for companies with that in mind, maybe you can attract them. Also, I don't want to support an individual team. Just be really honest here. If the team doesn't do well, right, doesn't necessarily look good, I would, now absolutely I might support the forum as a whole, right? That looks good because you're involved in new technology, but it's hard for an individual team to gain trust with a company, right? So those are just 2 points from an industry perspective.
Thanks for that perspective.
Yeah, I know, it's just, that's, obviously it's economist, but maybe it helps you think about how to attract industry.
No, it's a very good point and a very different way of looking at it.
Yeah, see, I just been one.
So that's a great segue to my question, actually. So one of the things we have trouble with engaging sponsors is trying to sell how the competition elements are actually going to contribute to their, like we're talking to port authorities or other people that might actually be sponsors for our particular team. And potentially in future competitions, if some of the elements might be more representative of some of the aspects, like I know you've got to, it's tricky to have what's achievable by students and other things, but around coal regs or some other aspect that we can easily, people would jump on that, oh yeah, that's a problem that we know, or the survey companies are interested in that type of thing. So it's probably just more of a comment, but if we can start to work in some of those dynamic environments with coal regs and stuff into some of the elements, it's a challenge, but that might help with getting some industry support for our teams as well.
Just for the benefit of the new team members in the audience, I'll just say, from a team's perspective, it seems to me that getting money from industry is hard, but getting components can be relatively easy. My RoboSub kids wanted an IMU, for example, and I was like, I told them, what would Hitesh do, right? He'd call him up and ask him for one. You make him say no, right? It's the worst that can happen. And so they called up VectorNav, and they were so happy that a high school team had heard of them. They were like, oh, what do you want? We'll send you one right now. Got one on the desk here. I'll put it in the mail today.
So adding to this, it's true what Zoz was saying. It's pretty easy to find components or discounts on components. Another thing that we try to do, and this year we had a good experience, is to invite companies to test their prototypes. So they're loaning prototypes to teams during competition, and they can actually refine the prototypes before they go to the market. So that's one option that we implemented, and it was actually successful. If it wasn't that, we wouldn't find the vehicle that we lost actually this year.
I was there. It was impressive. It was really impressive thing. We're getting to 3 o'clock, and we would like to stay on the schedule with the other session.
Do we have time for one more quick question? Because
well, this does kind of look into the future to a certain extent, because you've talked about upward integration into industry, getting them involved. To a certain extent, getting the larger community involved through entertainment. In the coming years, how do you, if you had an unlimited budget, in what way would you try to further integration downwards, down through the educational sort of structure? Because particularly in Australia, I don't know how other countries are, there's a certain gulf that happens between primary to high school that loses interest. And if these are very entertaining, if the information gets out there. So have you got any ideas what you plan to do over the next few years to try to extend that sort of involvement and integration?
So I can go a little more general maybe than it might speak more to Roboboat and RoboSub, RobotX. But from what I understand, the RoboNation organization as a whole has actually been looking into that. They have a series of competitions from, what is it, Sea Perch, Sea Glide, Roboboat, RoboSub, RobotX. It's a sequence of, you know, almost a roadmap where you can start at some of the smaller competitions and work your way up. We have someone who competed at RobotX last year with the Amber Riddle team, actually, who I believe she started with Sea Perch. Abby started with Sea Perch and has worked her way up as she's gotten older. I think she was 9 or 10 years old and has worked her way up through the competitions. And last year, at 15 years old, she was writing the software for the Roboboat, RoboSub, and RobotX components for that vehicle. And so I think the RoboNation, I would point you to RoboNation as a place that's already looking at that and trying to figure out how to do that. At least that's the one I'm familiar with. I can pass it along.
Yeah, with unlimited funds, I would implement science, engineering, robotics after-school courses, or even courses during the regular school year for elementary, middle, high school students. Because I know there's a lot of students who are interested in it. There's just no avenue for them to express it.
I don't have much to add. We are thinking on extending competition for high school also, making advantage also of contacts with people that are organizing already competitions like First Lego League or other competitions that are focused on high school, and actually they have the whole chain from primary school to high school. But we don't know yet how it will work and how we can actually continue after the transition between high school to college. That's probably the hardest part, I would say.
Well, let's thank our panelists for agreeing to join us.